Hello and welcome to this ETSI webinar. My name is Gavin Craig and I'm the Senior Technical Content Officer at ETSI and will be your moderator for today. This webinar has the title OSM Release 11, What Does OSM Do and How? It will be presented over the next hour by Francisco Javier Ramon from Telefonica, Gerardo Garcia, also from Telefonica, Ramesh Ramanathan from Tata Elxsi, and Mark Biel from Canonical. The session will be introduced by Francisco, followed by other speakers who will also provide a demo as part of the session. Francisco will also run the question and answer session at the end of the webinar. It's scheduled to last for up to 60 minutes, and then allowing time for the Q&A session at the end. Before I hand over to Francisco, I'd like to remind you of some quick points about our webinar today. A recording of this webinar will be made available on demand a few minutes after we've ended it, at the same location as where you are right now. Please feel free to ask questions by clicking on the question button. We will handle the questions at the end of the webinar. If we don't answer your question at this time, don't worry, we'll get back to you after the webinar by email. The slides in PDF format have been provided in the attachments section so that you can download them, along with a number of links mentioned in the slide presentation. Now, over to you, Francisco, to start the webinar.
Thank you, Gavin. Welcome, everyone, to the OSM Release 11 webinar. Francisco Javier Ramon from Telefonica. I'm serving as ETSI OSM chair, and I will give you a brief introduction of what comes in this OSM release. With me are some big members of OSM, big contributors, who will present different aspects of what comes with this new release. Gerardo Garcia, TC Chair, Ramesh Ramanathan, TC member, and Mark Biel, TC member, and will be the different sections highlighting some of the main features of the release and a couple of demonstration in the way. So without further ado, let's get started. So first things first, why do I need an OSM? This is a recurring question for newcomers to this space. So some people are well aware of what the NFVO does in the context of ETSI NFV architecture, but not everyone has clarity on why this is very useful in practice, right? What OSM provides is the capability of creating complex networks, virtualized networks as a service, and creates them on demand. So it takes as a starting point the services provided by the different clouds and SDNs and even physical functions that are available underneath, based on the models that we'll see later, is able to build bottom-up complex structures that make a whole network service, right? Or a network slices if needed. This is the goal of OSM, and OSM can provide that on demand in an urban interface. The point is that what OSM provides is a genuine multi-cloud approach. Means that all that I've described before as a service, it can be provided regardless what specific type of infrastructure we have underneath, what specific type of SDN, or even the distribution of Kubernetes that we are using. Is from the perspective of OSM and from the user of OSM and the modeling that you can introduce in the system is exactly the same as we will see in some of the demonstrations. The same goes for the distribution of our networks, of these network services across different locations. So we don't need to, one network service doesn't need to be together in the same location. We can distribute it as we need, which typically happens with networking that has a geographical shape, right? And on the other hand, the network functions are no longer of one single type. They're composed of, they may be composed of VMs, containers, physical elements, or a combination of all of them, right? From the perspective of OSM, they are in total interchangeable. And actually, we will see a lot of these and the coordination that may happen between them in a demonstration that Mark Bale will give in his slot on how it works, okay? In some specific cases, and particularly in private clouds, you expect a bit more, right? And you expect that they can support specific workloads for IO-intensive network functions, right? There are many techniques that are not that straightforward from the perspective of the configuration of the cloud to get them done, but OSM does it for you. So you don't need to pay much attention to these details in order to get your service up and running, okay? The point is, how do I make it? Now we know how we do it, but now from the perspective of OSM, everything is model driven. I mean, we are making our network functions and scenarios as part of a definition that is portable and reusable, right? So all this is composed in a set of network function packages and network service packages that compose those network function packages. The point is that we can deploy the same thing in different clouds, as we are seeing here, even in different locations, but we can still particularize how that the part of that deployment goes from in things that can only be location dependent, say addressing, or say some parameters for the keys, or some sizing. So that kind of stuff can be particularized upon instantiation time, right? So here is a central point in OSM, the modeling, and that modeling is materialized in an OSM package, which embeds everything that you need to deploy consistently across different clouds, different locations, and so on. So it's agnostic to the type of infrastructure. It can be parameterized, as we said, can be customized upon instantiation without entering into rewriting the whole package, and very important, can include even the full life cycle if needed. So the day 2 can be run from OSM, and actually we'll see in detail how some advanced aspects of that day 2 can be achieved, besides the ones that were available in previous releases. Okay. From the perspective of OSM community, a brief update. I mean, OSM keeps growing, and obviously, given its size, it's difficult to find additional players, but we are quite happy with 150 members today, but open to new participants as always. And we believe an excellent mix of the different type of players in the in industry, the different type of players in research, and all the know-how that is needed to maintain this bet in all these layers and all these techniques that are required to get to realize the vision of deploying on demand model the network services, right? The same goes for the OSM ecosystem. Here we are listing commercial offers that are related to OSM. This is an opt-in list, so it's not an exhaustive list of everything that is here and there, but we think is representative of how we are positioning in OSM community the different pieces. And as you can see, the OSM ecosystem keeps growing from one event to another. We are really glad, and also we are really happy on the impact that OSM is having in the research community, that is becoming the orchestrator of choice for the different research projects around 5G and Edge. And now we are talking about the new release 11. What comes here? I mean, for those who are familiar with OSM has a lot of functionality. Most of it was already covered in previous releases, but here we have added some improvements of what we had. First is that we have improved our alignment with Edge, the work of HCNV, including the support of two specs, Sol 4 and Sol 7. Ramesh will tell you a bit about that and how is the current picture of our alignment. Also, we are extending the multi-cloud support, and particularly the case of public clouds. adding also support to Google Cloud, which makes, is completing the support of the three big players of public clouds from OSM. We have AWS. In the past release, we have Azure. Now we also have Google Cloud, right? From the perspective of Kubernetes, we had a strong support already in release 10, but now we are extending it with some operations that are really useful in operation, but not necessarily trivial operations from the perspective of a Kubernetes environment that are not easy to get out of the box, but with the addition of these features, you can enjoy them from OSM, starting and storing the services in the containers, running one-shot commands, and an API for files. I think that this is always achievable, but now you have all the tooling to achieve it easily, right? We have also improved the coordination across PNFs, VNFs, and CNFs. I won't spend much time because we have a full section devoted to this, illustrated with really good examples, I think. We have improved also the monitoring of the own Kubernetes clusters, so we can see in real time what is going on in the clusters where OSM is deploying workloads. And also we have improved our installation process. We are now taking as recommended distribution Ubuntu 20.04, and we are improving the way that we track any potential issue in the installation process, so we can make the troubleshooting much simpler. Okay. As I said, the set of features, what I've described at the beginning, and this is really comprehensive. We are launching the 11th. We have launched the 11th release. So it's complicated to be exhaustive in the description of what OSM does and the capabilities and so on. So we have chosen to, demonstrate it by examples, and we think this is much simpler, and this is the approach that we'll follow also in this webinar, so you can get a better idea on how OSM can help you. Okay, and now let me introduce a colleague, Gerardo Garcia, TSC chair, who will tell you about multi-cloud deployments. Over to you, Gerardo.
Okay, thank you, Francisco Javier. Well, I thank you everybody for attending this webinar. My name is Gerardo Garcia. I am from Telefónica. I am the chair of the technical steering committee, and I'm going to present a demo of how OSM could help and in the deployment of complex network services, real network services in different clouds, what we call frictionless multi-cloud deployments. So the main idea of the demo that I'm going to show is that we could easily reuse whatever is tested in a lab, whatever packages that we have created and we have already tested in a lab could be reused again in any production environment, no matter if it's in a private telco cloud or it's in a public cloud. And that's the idea that I'm going to show. I'm going to illustrate the demo of the onboarding and instantiation of a real network function, PCF's, Oracle's PCF. PCF is the policy control function in 5G. Okay, and what we have done is basically we created the packages for a private telco cloud in production. That was the starting point. We already made that effort, right? And we took those packages, and once we validated them and we were sure that they were okay, we redeployed them in different clouds. In this case, in the demo, I will illustrate the deployment in Azure and Google Cloud. Okay, but it could happen in AWS or in another private telco cloud. So we are talking about the three main public clouds: AWS, Azure, Google Cloud, but also the private telco clouds that could be based on OpenStack or VMware integrated OpenStack. Okay, so and the main idea is always the same, right? Is that we could reuse the packages always that have been tested and validated, and we could reuse them to deploy. And the only thing that we will change is the instantiation parameters that, as you will see, they are minor changes from one cloud to the other. Okay, I will illustrate that also in the demo. Well, just a few comments about the network function. The network function is Oracle's cloud-native core policy that it's a coverage solution for 5G and 4G. Okay, so for 5G policy control function and for the PCRF function in 4G. It's a containerized network function, a CNF, what we call a CNF. It's a mix of different tiers, right? It's basically consisting of three main tiers, right? The core policy, that it's the function itself, right? That it's stateless, and then we have the DB tier, that it's the database that is the one managing the state, right? And the monitoring tier, that it's basically a combination of common open source tools like Elasticsearch, Prometheus, Grafana, okay, in a tier, and they provide the monitoring part of that PCF, okay. So they are monitoring the sessions that are created, well, and the active sessions or the status of the different pods and deployments over there, right? That's what's part of the whole solution for the network function. The deployment was prepared for convenience as a set of network functions and network services. We created 8 different Vnf packages, and we combined them in 5 network services for convenience. I will illustrate and I will onboard them and I will comment, okay? But it's just a matter of convenience in the way that they were managed, right? So for instance, there were 3 network services for the monitoring part, one for the DB tier and another network service for the PCF itself, right, the core policy, right? So I think that that's enough as an introduction. I will move right now and I will show you the demo with OSM Release 11. I think that you could see right now my screen. This is the graphical interface of OSM. So I will going to log in as Gerardo. I'm going to, for the purpose of illustrating the onboarding process that you probably already know, but just for the purpose of that, I'm going to switch to the project demo onboarding, so that I have an empty project so that I could illustrate how to onboard Vnf packages and network service packages, right? Well, onboarding is pretty simple. You just go to the Vnf package section and you just drag and drop the different files. So I'm going to take here the packages. Here I have the packages and I have the monitoring tier. So I will onboard all of them, right? So, well, you need to take into account that they were created, okay? And just once they were created, you could reuse them in any, just to be redeployed again in any other cloud. So that's what I'm doing, right? I got the ones that we had and I just onboarded them. We have here the monitoring packages, okay, of the Vnf and the 3 network services here, right? Well, I think that it's pretty simple, right? You get the picture on how this works, right? So in the end, you end up here for the monitoring pack with 5 network function packages and 3 network service packages. Then, as I mentioned, there are other tiers, the DB tier, right? So I will need to onboard those 2, okay? So I will onboard the DB tier packages here and here, and the network service package for the DB tier, right? And that's all. And for the PCF, all them. So sorry, it was not a network service package, a Vnf package here, and another Vnf package here, and network service packages here. Well, so that would be all. I have already onboarded the different packages for deploying the PCF, right? The 3 tiers of the PCF, right? These are the Vnf packages. These are the network service packages. Okay, the next thing that you need typically to do is just to register your case cluster, right? So you would go to case cluster, add case cluster, okay, the name of the case cluster associated to a VM, and pass here the kubeconfig file or the credentials file of that Kubernetes cluster, right? So that's what I have already done. I have already done in a different project. It's the one that it's called multi-cloud. So I will switch to that project right now, and I will show you what we have in that project. So I have here two clusters, okay? A cluster in Azure and a cluster in Google Cloud Platform. I have the same packages there, Vnf packages and network service packages here, right? And for the in order to make the demo agile, okay, and quick, I have already instantiated I have already deployed this in Azure, okay, and I will illustrate how to instantiate it in Google Cloud. So if we go to the instances right now, we could see that I have created 5 different instances in Azure. The Elasticsearch, Elastic Tools, and Prometheus are part of the monitoring tier, the 3 network services of the monitoring tier. Then the DB tier and the OC PCF in Azure. Okay, so that's already deployed. Okay, we could see it right now in Google Cloud. Let me show you. So this is the Google, sorry, in Azure, we could see it, right? That we have here a PCF cluster in Azure, right? We could check the workloads there, and you will see that, well, everything is running there in Azure. Okay, we could check, for instance, some of the components there. We could check, let's check, for instance, the main config manager, right? The different services. Yeah, the services here. For instance, we could check the config management server. This is here. Okay, it's in port 8000, so I will change that, and we could access to the management interface, okay, of Oracle PCF, right? Well, we have everything here, the session viewer. It's normal portal that you could use for the configuration of the PCF. We could also attack this gateway. This is the main, let's say, the entry point of the PCF, right? So I could create sessions against this PCF by just creating them against this IP address here. And that's what I'm going to do. Okay, I'm going to use for that a generator that we have created. It's an HTTP2 generator that it's pretty simple. I think that, well, you will follow what I'm doing, but just I will use the console for that, okay? And let me paste here the command to generate some sessions. 1 second, it's here. So I'm going to create the sessions against the endpoint. This is the endpoint 20.101.231.189. It should be the endpoint of the ingress gateway. If I'm not wrong, it's this one here, right? And I'm going to create 100 sessions with a timeout of 10 seconds in case any problem happens, okay? But it should, okay? So I'm creating sessions and I have positive response to 101. Okay, so they have been created right now. And just to illustrate that, this is to illustrate mainly that it works, right? And I will switch right now to, I will show you that those sessions are actually created by accessing the Grafana portal here. So let's go to the dashboard. It's here, PCF dashboard. So you see that the 100 sessions that I have created have been created here. They are marked as active sessions, right? This is the rate of association, policy associations create requests, okay? And this is the actual sessions being created that it's 100, right? Well, so it's working, right? It's real. Now what I'm going to illustrate that it's also possible to deploy it in Google Cloud. So I'm going to illustrate how the process will be more or less, okay? So first of all, just to tell you that we have also the cluster that we have registered in Google Cloud. That cluster, let me show you that there are no workloads there, right? So for the moment, there are no workloads, right? I will deploy there and I will show that the different pods are created, and later on I will create also some PCF sessions or some policy associations, right? So let me go to OSM right now, and let's go to network service instances, and let's create a new network service instance, right? So we will have to create 5 network service instances, right? One for each of the network service packages that we have. So we'll start with this one here, PCF Elasticsearch in Google Cloud Platform. Description, I will put the same. I will use Elasticsearch Network Service. The Vim account is GCP. By setting the Vim account, we are also discriminating the cluster to be used, okay? Because each case cluster is associated to a Vim account. In this case, there is a single case cluster, so there is no ambiguity. And then we pass here the configuration. That's the instance parameters that we want to pass, right? So, and the instance parameters are here, same webinar packages, this one here. Okay, this is well, this is the whole set of parameters that we are passing. It's too complex, but I will explain right now in a minute. Okay, I will deploy, and after some time, this will be ready. Obviously, we have to deploy 5 network services. I'm not going to do all of them. I will shortly pass the turn to the next speaker, that it's Ramesh, and later on in the end of the session, I will show you that everything is running. But meanwhile, just let me only illustrate the kind of parameters that we are passing as part of the instantiation, right? And for that purpose, I have selected for instance, the parameters for the core PCF, right? This is the difference between in this figure here on this screen you are seeing right now, the difference between the parameters for Azure, for the PCF, that's the left part, and for Google Cloud, that's the right part, right? As you can see here, the only difference for the PCF between for the instantiation parameters to deploy in Azure and Google Cloud, the only difference is the repository. That means the Docker registry. This is because we created different Docker registries for both platforms in order to save some network bandwidth, right? And there are only 2 changes, right? The only reference here to the Docker registry. Okay. It's also true that there is no, I mean, the PCF tier here is stateless, so there is no storage class, any storage. So that's the reason why the only change is this one. But if we go, for instance, and check for the DB tier, for the databases, what are the changes, we could see that it's not only the repository, but also the storage class name. It could happen that the storage class names in Azure and Google Cloud might be different, and that's the second change that is typically done, okay? But from a set of, I don't know, 700 lines, right? Or 800 lines, only 2 lines of changes between one cloud and the other seems very few, right? And the same for the DB tier, right? From 200 lines, like 5, 6 changes, okay? It's very reasonable, right? And that's all we have to do to deploy it and to differentiate one deployment from the other, right? Well, so that's the idea. I will work right now in the deployment of the rest of the network service, and I will illustrate later on in the end that I will show you that they are working in Google Cloud. Okay, just a few conclusions from the demo is that. Well, I think that it should be more or less obvious for you right now after demonstrate that the use and the reuse of packages brings obvious operational benefits to the telco operators, right? Mainly, we don't need to test and validate everything again, right? Once it's done, I mean, we are confident that whatever will be deployed will be working again very quickly, right? So the time to market also is minimal. The human errors are expected to be very few, right? Because of that. Thanks to the introduction of new connectors and to interact with the different clouds, there is no lock-in with specific clouds. And obviously, if you are a global telco operator, like in the case, for instance, of Telefonica, we are able, for instance, to share the different packages between the different business units, different OBs, so that it's possible to reuse them, right? So that's also a benefit. And at the same time, the capability to deploy in different clouds is opening the possibility to other advanced deployment scenarios, like could be the ability to move workloads between clouds, or well, advanced HA schemes where we could have different replicas or different replicas of the network function, let's say, in different clouds, right? Well, and that's all for the demo. Now I would like to introduce Ramesh Ramanathan, that will give an overview of OSM and the relation with Etsy architecture, right? Ramesh?
Thank you, Gerardo. Welcome again, all. Thank you for joining us today. So, so far we saw a very interesting view on open source Mano from its capability perspective, its ability to interact with multiple clouds, private, public, hybrid, all driven by APIs, right? Connecting to systems on the southbound, northbound, different types of NFVIs to create services and functions across the different domains. So the next two slides, we are going to look into, so what drives this connectivity? What drives this ability of me to model these services? We just saw Gerardo take just a single model, and then he was able to deploy it across multiple clouds, right? So what drives this modeling? What drives this API communication? That's what we are going to see in this, and the advantages in the next slide. So when you talk about this modeling and API, another way to view is, which we are very excited about, is the openness, right? And when we talk about openness, it starts with the standardization to drive interoperability, to bring in an open ecosystem, and then of course the applications and the use cases that we get out of it. So to begin with standardization, open source Mano under the hood, we all saw what it's capable of, but under the hood, we are looking at a program that is driven by HC standards, compliant to the HC architecture and the key solutions driven by HC. So to begin from the top, we have the NFV orchestrator, the NFVO functionality, which is supported by OSM. So on the northbound, it exposes Soulfy APIs through which you can connect to an OSS/BSS system. You can take out JSON object models to put in a configuration management database. Connect it to a NOC for alerts and notifications. Register lifecycle events of services across the different domains with either a NOC or an OSS system. So any kind of integration, be it either a push or a downstream instruction, right? For example, if you have a NOC that does data correlation across the different domains and wants to take a closed loop assurance policy to do a healing or a scaling, we support all of those APIs in the northbound. So either a northbound system, an OSS/BSS from a fulfillment, from an assurance perspective, as well as open source Mano to feed back the lifecycle changes, the alerts, the notifications, all of that is supported and adhering to the Soulfy standard. That's what we expose on the northbound. The UI that you saw, as well as a CLI, is built on top of these Soulfy APIs. And when we come down the stack, a notion of a Vnf manager, we call it as an LCM, and this has a capability to interact with Vnf other Vnf managers or EMS. It can be through a Juju charm, it can be through maybe a Soul3 plugin we want to write, and as well as an ability to directly talk to the VNFs or the CNFs. Right? So as we evolve on this virtualization journey, right, there are a couple of possible architectural elements. Either an orchestrator can directly talk to the VNF CNFs, or it can be via the VNF manager, the new age EMS. Right? So with TOSM, both the models are possible to do your fulfillment, day 0, day 1, day 2 assurance activities. And on the south, Vim, a virtualized infrastructure manager, to talk to the different types of NFVIs. Right? In the previous demo, we saw an example with Google Cloud, Azure, similar with OpenStack, VMware, all of them abstracted by the Vim. And in this Vim, you have an ability to configure the different tenants, policies, create availability zones so that it gives you complete control of how you want to structure your deployment and which VNFs need to go into which zones, so that you have a system that is easy to design and easy to replicate as well. And when we talk about the services themselves, right? So we kind of looked into the Solfi APIs on the top, and then of course the ability to talk to VIMs and Vnf managers, but the input services, the modeling, right? So we covered the API part. So when we talk about modeling, we are adherent to Sol 6, which is the YANG-based HC standard for modeling next generation network, as well as Sol 4 and Sol 7 for packaging of the VNFDs and the NS. So in the previous demo, we saw Gerardo upload VNFD packages, right? And then build services out of it, right? In the designer studio of open source Mano. So these packages as well, we conform to the specifications of Sol 4 and Sol 7, which makes it very easy for vendors to build solution and onboard and interoperate with OSM as an orchestrator. And then the modeling language, like I said, is Sol 6. So with this, open source Mano provides operators a single file, a single YANG file, a single plane of glass, where you can just express your business intent in very simple terms, and the entire implementation is abstracted and taken care of by OSM. Hence, OSM being a zero-touch automation engine, right? Where you express your intent and the actual implementation is abstracted from you, and it could be, bringing up the VIMs, deploying the services, KNF, VNF, multi-cloud, all abstracted by the implementation that OSM brings in. Right? So this is a high-level overview of the standards that I adhere with, and what are the features that we bring along with it. And the reason this is very exciting is this openness, right, enables our customers and as well the community to build open platforms out of it. So with this standard-based APIs, a quick way to connect to different ecosystems to quickly integrate open source Mano into the telco environment, or even large enterprises for that matter, to build the telco cloud and roll out the solutions. So this includes plugin connectivity for LDAP, DNS, NTP, DHCP, APIs to pull the data out, the metric data that we collect. It could be the infrastructure data, it could be the service data, right? Or on the assurance part, we can collecting the data, setting policies, or pulling the data out to a big data platform outside for high-level correlation and data analytics, as well as connecting to a variety of NFVAs, Azure, GCP. We saw in the previous demo, OpenStack, basically on-prem, on the cloud, hybrid, SDN networks to program the DC, right? So SDN controller to program the leaf and spine switches, for doing the EPA programming, for programming the private networks in which the VNFs and CNFs are going to be deployed. So when you view this in a holistic manner, this open platform telco cloud will brings in quick integration, interoperability, standard compliance, gives you a very rock solid and rapid way to roll out an entire DC for a telco in the telco space. Because when you look at these APIs, it gives me a quick way to onboard an NFAI, do the entire modeling of the VNF and CNFs, deploy them, assure them, connect to the different OSS systems, program the leaf and spine switch, the connectivity for the private networks. So what we see here is an end-to-end ability, not just for open source manner to fit in easily and elegantly into a brownfield telco network, but also the ability with these APIs, with the standard compliance on the open platform to very quickly visualize and bring up a data center for telco operators. So that's the advantage. So it's not just about meeting the HC standards, but the utility of it, the use case of it is the quick way you can start going, model your services, integrate even into a brownfield environment, design, program, and quickly lay out the DC. Right? It's as simple as use open source manual to hit a SDN controller like Nokia Nuvage, program the reference point, decide on a network topology, roll out the VLANs, call open source manual, where in the descriptors you can mention these designs, right? Like what is the VLAN, what is the IP subnet, and then you can go ahead and then deploy your services and roll out the DC. So this is what we bring in with openness and the power of the open platform from an open source manual perspective. So with this, I'll hand it over to Mark, who is also a TSC member in open source manual. So over to you, Mark.
Thank you very much, Ramesh. Thank you, Gerardo, as well for a great beginning and overview. So what I'm going to be showing and talking about now is going to be a little bit more diving into some of the integration between different types of network functions. So Ramesh had talked about brownfields, and the reality is that not everything is going to be a virtualized function. Sometimes we're going to have to deal with legacy systems or physical appliances where we're not actually going to be able to, add code to it to be able to orchestrate it. We will have to talk to it, from the outside and be able to perform day one, day two operations to configure it and adjust it to the environment that we're automating through open source manual. So I'm actually going to be giving a very simple network service as a concept. So the first thing that we've got is we've got the user coming in from out over the internet. They need to reach our network services that we're exposing, but of course, we're going to be putting a firewall up to make sure that we're protected. Now, this firewall, I'm calling a PNF, or physical network function. In this scenario, this firewall is something that has been set up by our security group, and we can only talk to it through its exposed APIs. We can't put any code on it. We're not managing its lifecycle. It already exists in the network. So open source Mano does have a concept of being able to register physical network functions with it so that it can perform operations on a physical network function. So the first thing that we're doing is, in our network service here, we're defining that, okay, there's going to be this firewall entity, and it already exists, and it already has its own IP address and credentials and whatever we need to talk to it. The next thing that we're deploying will be a load balancer. And so this load balancer is something that sits inside of the network premises, and the firewall will need to be open to talk to our load balancer. That load balancer can then, forward traffic on to different application CNFs or whatever it is that we have in our back end. So I'm going to dive in a little bit on how does the load balancer and firewall know about each other and how to open ports. So there's an information exchange that needs to happen between these two services, one being physical, one being a virtual appliance that we just deployed. So the firewall has to open ports and forward traffic to our load balancer. The load balancer will need to know the IP addresses of the backend CNFs or whatever ingress is exposed from them. And the CNF units or even the load balancer itself could be scaled individually. So all of these things need to have a coordination between each other in order for the end-to-end traffic flow to work. So what does this look like? As part of a network service descriptor, you have what we call multiple, VNF descriptors. Yeah, these VNF, we use the term V rather loosely because a VNF could describe a containerized network function. It could describe a network function that is implemented using virtual machines, or it could actually describe the PNF that we want to talk to, an existing physical appliance that's been registered with OSM. So we know on the one side, we have our firewall. It's up and running, and it needs to know what ports to open and the target IP address that's going to forward the traffic to. Over on the load balancer side, well, it's the one that knows its IP address and port and the firewall port that it wants to open. So that's the part of the data that it's going to provide. So on the one side, the firewall requires some information so it can open the port. And on the other side, we have the load balancer that will provide that information. So these terms requires and provides are used to help us be able to determine, well, who needs to supply what information and who needs to consume that. So both of these things will come, will be pulled together by open source Mano. As part of the network service descriptor, I can say, well, this one VNF that I'm going to be deploying provides a certain amount of information, and this PNF that already exists requires that information. So it's going to establish that relationship between them. And as things are starting up and being deployed, it will then go ahead and exchange that data, allowing the firewall to open its port and forward traffic to the load balancer. So what does this look like? What I've done is I've zoomed in a little bit to a portion of the network service. So the network service itself will contain information such as, well, I need this VNF deployed, I need this PNF. As Gerardo showed, there'll be things like networks that are used, storage that's used, compute power, CPUs, memories, all that sort of stuff. And as part of the network service layer, which pulls all of these virtual network services together, we say, okay, at the network service, we need to have, a couple different things deployed, and we want to relate them. So I've just given this relation, I've given it the arbitrary name of Firewall Load Balancer. And the provider and requirer, you can see they both have the same name for an endpoint. That endpoint, again, is something that I simply, chose to call firewall rule. It can be arbitrary as well, but typically something that you would want to describe it. And the provider and requirer will be matched up in the network service descriptor. The last one is the VDU profile ID. And what this is it specifies, okay, which VNF is going to actually be providing the data and which one requires the data. So that way we know how to relate the two of them. So the provider, as I mentioned, is the load balancer, and the one that requires information is the firewall. So I would have named one of my VNFs, I would have named it load balancer, and the other VNF I would have labeled firewall. And that's how these things are tied together. Relation events that can be fired. So OSM leverages Juju as a technology for day 1 and day 2 operations. And these are relations that can happen, events that can happen in a relationship. So the first one is relation joined, and that's just simply a notification that a new relation will be formed. It is possible at this point that the load balancer isn't fully operational yet. So typically, unless there's some preconditions that you need before your software is available, kind of day 1, the relation joined is not all that significant. The relation changed is our primary means of data communication or data exchange. So this is what it allows us to send and receive data between deployment units. And it's possible for a unit to cause a data exchange to happen based upon its own timeline. So, for example, if I have a load balancer and it needs to do some sort of reconfiguration, like maybe it needs to change its port, we don't need to delete the network service and redeploy it in order to have that. As the load balancer learns about its new environment, it can send new information over the relationship for the firewall to consume. The next significant event is relation departed. And this is the notification that you'll receive when the network service is about to be torn down. So as the network service delete or termination starts, first you'll receive the notification departed event so that you know, hey, my load balancer is about to be deleted. And then once it is deleted, you will receive the final relation broken event. So that's after all units have been terminated, the relation broken event will happen. Now, of course, we have to ask, well, how is it that I'm able to receive an event if the service is already being deleted? So what happens with open source Mano is, we're deploying the network service. So the firewall already exists, and we've deployed the load balancer on, say, OpenStack or the virtual infrastructure manager. This is sort of part of the power of OSM. Along with deployed network functions, we also can create execution environments where code can execute on behalf of the deployed service. So remember, I was saying how we have the physical network function and it's locked down by the security department. All we have is an external API for it. So how do I execute code to be able to say, hey, log into the firewall, use its external API, and open a new firewall port? I need somewhere for that code to run. And these are the execution environments that go along with network services that give OSM the power to be able to perform day one and day two operations. So these are environments that are created depending on your deployment and how you have things set up. They could be executing in the same area as OSM, or they could be executing closer to your network functions. So there's the ability to distribute some of these things as well. So once the execution environments are created, the execution environments are the ones that are going to be aware of these relation events. So we have our PNF, it's already there. Our load balancer was just deployed as a VM, and the execution environments are created, and they will be receiving the relation joined event. Once they're up and running, we're actually going to receive the relation changed event. So both of them receive this notification saying, okay, the relation has changed, which means that everything is up and running. We are good to go ahead with starting to perform our day one configuration, basically to establish the open firewall. So now, on my load balancer execution environment, I say, okay, I've received the relation changed. So I'm now going to let open source Mano know, this is the port that I need opened, this is my IP address, and this is my port. OSM will then fire the relation changed event again over on the PNF execution environment, and it's going to receive that data and say, oh, okay, I'm going to use the API of the firewall, and I am going to tell it this port needs to be opened and forward any traffic on that port to this target IP address. When we remove the network service, of course, the PNF is not going to be deleted. It will stay there. Our firewall is going to remain, but our load balancer will be torn down. So what we want to do then is, in the execution environment for the load balancer, we can say, Well, let's listen to the stop event that is happening. And when we hear that, okay, we're about to be stopped and torn down, we can then say, well, here's the port that I would like you to close and my IP address and IP port just in case you need it again. OSM will then turn around and go ahead and let the execution environment know, hey, somebody sent me updated data. The relation has changed. Here's your new information. And it will go ahead and close that port with the target data from the event. So this is a very sort of simple, data exchange. Things like being able to exchange certificates for internal services is another way of being able, another thing that could be expressed using a relationship, so that a certificate can be trusted, or perhaps keys for credentials. Any of those sort of things can be exchanged as part of a relationship. The last thing that happens then with on removing the network service is OSM will go ahead and tear down the execution environment and the VNF, and the PNF will remain untouched because we do not manage life cycles of PNFs. That is by definition what they are, something that is to be managed with OSM, but its life cycle will not be controlled by OSM. Lastly, once the load balancer is gone, we will receive the final relation broken event. And that one we could use to double check our firewall if we have some sort of state, basically going, okay, let's just query the firewall, find out what ports are open, and make sure that we didn't leave anything behind. So you can do final cleanup or that type of thing in the relation broken event. So here I'm showing a little code snippet of Python, which can be used inside of the execution environment. A lot of execution environment stuff is written in Python just because it's a relatively straightforward language and easy to use for scripting. And basically, we have on firewall load balancer, which was the name of the relation that we described in our network service, relation changed. So we're going to receive the event, and we're going to be able to put data in that event. And when this function returns, OSM, the Juju component of OSM will see, okay, there was a change in the data, so I need to fire this off as a relation changed event to the requirers of the relation. So then over on the firewall side, the PNF execution environment will have the same method called, but the event is going to contain the data that was sent by the load balancer. So in here we can see, well, we're going to pull out the port, target address, and the target port from the data that was sent to us by the load balancer. And then we're going to call an internal function to go ahead and add that as a firewall rule. For further information on events, they are documented in the Juju documentation, as well as we do have documentation for OSM and how to use, how to write network services and things like that. So this concludes my overview of data exchange. And what I would like to do is invite Gerardo to come back and show us the results of the Oracle PCF deployment.
Sorry, I was mute. Yeah, I need a few minutes so that the deployment is right now ongoing, and I need a few minutes to wait for the deployment to be ready in Google Cloud. So meanwhile, I suggest to move to the Q&A questions and then come back to to the deployment in a few minutes, okay, once it's finally ready, okay?
Okay, let's do that. Okay, so we can start by one question. Here, it has been mentioned in the demo that this multi-cloud capability can help to move workloads between clouds. Can you elaborate how such a scenario would work in practice?
I can take that one, Javier.
Okay.
Yeah, I think that, well, yes, definitely OSM could help. The strategy to migrate workloads, I mean, migrate workloads between clouds is something that it could look like very complex, and indeed is not straightforward. But I think that there is a strategy that works well. We have been experiencing with it in Telefonica, is the deployment of a second instance in the different cloud, configured with the same packages, the same configuration, everything that could be done as a normal instantiation, as I have shown right now in the demo. And what could be missing from, in order to let's say make sure that the function is working exactly in the same way, are to the other mechanisms that are required, right? Besides that second deployment, right? We need to make sure that the clients that are talking to our application are reaching the second deployment, right? Whenever we want. For that, there could be different mechanisms. There could be, for instance, if they rely on a DNS, we could make use of that DNS. We could set different endpoints for the DNS, and we could switch from one to the other. Okay, there could be application load balancers or application functions like NRF or others in the 5G world. Okay, that could be used. Okay, these are the kind of things that could be done in order to, let's say, switch the traffic between one deployment and the other. And there is something else that would be required if the network function is stateful. And by stateful, I mean that it's mainly for instance, there could be two kind of network functions with a state, right? One that it's with ephemeral state, let's say sessions. The other is that with permanent state. That's probably the one that we need to take carefully, right? The ones that were, if the network function only has sessions that expire, probably we could deploy the second instance, just switch the traffic so that the clients go to the second instance and just wait for the sessions to expire. That could be a possibility. If the network function has permanent state, we should need to have a tool or an additional tool, okay, that could help in that transference of a state, right? Mainly backup and restore tools like the ones that are used for disaster recovery or any kind of replication between databases, okay? I hope that this answers the question.
I think so. I think so. It's been quite explicit. Actually, what you have mentioned about the different components that need to be coordinated is quite related to what the scenario that Mark has expressed. I mean, there are different pieces here and there. Not all of them are necessarily virtual. There might be some PNFs in the way. There might be some elements that need to be or are even subsystems where you need to trigger an action. So you are rebalancing, redirecting the traffic. You are moving, triggering some elements that are capable of for disaster recovery and recover the state over the second instance and all the like. So that falls in the middle of what is the actual type of orchestration, right? It's not that you have different components that you reconfigure them more or less cleverly and coordinate the different subcomponents, but also that you are making an actual network service where you are coordinating things that are going on at different places. I think that this gives us also the opportunity to see all the new things that we are seeing in Release 11 together. You are not forced to coordinate them in that way, but OSM can definitely help you on that. So I think that is the benefit, right? Okay, we have okay, we have more questions. Okay. Okay, so let me see. Okay, so there is a question about Vnf management. So this is what about interoperability between different Vnf manager in OSM? Can a user integrate different Vnf manager with OSM? Maybe Ramesh would like to answer this one.
Sure, Francisco. What about interoperability with different VNF or integrate different? Yeah. Okay. So when it comes to integrating different VNF managers with OSM, yes, we can do that. So it can be for a variety of purposes, like it can be to instantiate the VNFs, to configure the VNFs. So that interface is achieved using the Sol3, right? So Sol3 is the interface we have between OSM and a particular VNF manager that is provided by a vendor. So that support is something that we are now bringing it into OSM. So with that would be a library with which once you have onboarded the VNF manager and the VNF, right? Like you're deploying an actual network service, right? The VNF manager would also be like a network service that you would deploy. So once deployed, using the Sol3 library, you will be able to write charms for it through which you can control the VNF manager to to configure, to fulfill, to assure, to read alarms for the particular VNFs that are controlled by the VNF manager.
Yeah, in
Okay,
addition
thank you.
to that,
Okay, go for it.
Yeah, in addition to that, well, the function of the VNF manager itself is part of OSM. OSM encompasses two functions, okay, the VNF manager, generic VNF manager, let's say, and NFV orchestrator. So it's part of it. A different thing is that OSM is not exposing that interface directly, okay, to outside, okay. But I think that well, that would complement somehow the answer from Ramesh.
Thank you, Ramesh, Gerardo. Regarding the okay, so there are other questions. Are the different descriptors packages using the demo available as example? Are they use CNS based on Helm charts? Well, it's two questions in one. Maybe for Gerardo, I guess.
Yeah, okay, I'll take it. The packages used in the demo are private, so they won't be publicly available. Okay, at least for the moment. Regarding the other question is whether the CNS are based on Helm-Charts. Yes, they are based on Helm-Charts. That's the what the vendor, in this case Oracle, provided. Okay, and the integrator that we had in the UK, okay, that's what they provided, and that was the starting point to build the packages. Exactly.
Oh, okay. Okay, as a complement to that, I mean, in OSM's website, there is a comprehensive list of examples, right, that illustrate really well equivalent example to this one. I mean, obviously here the thing is that these are a commercial CNF, so I mean we cannot redistribute them freely, as you may imagine. as much as we would like, right? But it's not a possibility, right? But if you check in our site, and maybe we can provide a link for that. There are multiple examples that are pretty similar to what you have just seen. Okay. Okay. One additional question. Is the standardization alignment means that OSM now supports deploying both Yang and Tosca packages? Who would like to take this one?
Yeah, I can take this. So in principle, in principle, in terms of the functionality, I would say yes, in the sense that both the Yang and Tosca package formats, modelings are derived from the same IFA standards. The IFA 11 gives you the standards for the VNF, and IFA 14 for the NS, and both Sol 1 and Sol 6, which correspond to Tosca and Yang, are derived from the same standards. So all the functionalities are present, irrespective of in OSM as per standards, irrespective of the choice of model. But in terms of the package support that you have to bring it in, it is OSM expects it to be Yang model. But however, with a converter, you should be able to translate the Tosca to Yang, so that seamlessly, even if the vendor brings in Tosca packaging, you should be able to use it with open source manual.
Thank you, Ramesh, for your question, for your answer. Sorry. And I think that we have no additional questions left. So thank you, by the way, because they are giving us a good excuse to explain other aspects that could not be thoroughly covered during our presentations of Release 11. So maybe this is a moment to come back to our deployment. Gerardo, what do you think?
Yes. Let me share right now my screen. Okay. Well, I don't know if it will be ready on time. Could see right now the screen. Right now, well, there are the different things that we have deployed in Google Cloud. There are from the 5 network services, 4 have been completed. Okay, the 3 related to the monitoring tier and the one of the database, and the one for the PCF, the core function, it's right now under deployment. It will finish probably in 2-3 minutes, but meanwhile, probably I would show that the different objects have been created in the cluster. And let me show you here, for instance, the workloads here. If I refresh, if I go to the Google Cloud platform, to the cluster, this is the cluster, and we see here the workloads. We could see that there are, right now they have been created, all these workloads here. Okay, the different stuff, all the things related to the management, and there are things related to the PCF that they are right now being also deployed. So, well, I would like to make a demo of all I could show, for instance, right now, probably until the PCF is ready, is that the Grafana dashboard is available. So let me show you. This is the Grafana dashboard here. I could go there, I could go here, admin, and it's there, the Grafana, right? That's all I could do right now, because the rest of the PCF is right now under deployment. Okay, so well, Grafana is working, and we could see there the demos. I think that's all. I think we will need probably 1 or 2 minutes to have it completed. Okay. Right now. Well, almost on time. Okay, it's real. So that's the good point. Okay, so let me show you, for instance, the portal of the config manager. Okay, that it's in the here. Let's go there. Let's go to the management server here. This is the main portal, okay, for configuration, okay, where we could see everything, general configuration, session view, and etc. And we could create sessions against the ingress gateway here. This is the IP address that I will take, and I will run the tested against that. So sorry about that. This is the PCF tester. I will create create 100 sessions against this IP address here, that is 35.246.55.121. Okay. And well, first session takes more time because it's creating some of the necessary structures in memory. Okay, and the next sessions are going quickly. Okay, so well, it seems that it's working. So 100 sessions being created, and I will go to Grafana to show that everything is there. By the way, yeah, let me show you here. I will import the dashboard. Yes, this dashboard here. And we should see in 1 minute, well, we see here that it's running from 2-3 minutes ago. And we will see that the sessions start to grow here. The active sessions start to grow here in a few seconds. Okay, that would be all, I guess. I mean, we could give some time to the sessions to appear. I could continue sharing. I don't know if there is a final question, maybe, just to close up while we are seeing the sessions.
Not so far, but I'm seeing the sessions arriving.
Yeah, right now they are there. Yes.
So yeah.
The monitoring takes some time. Okay.
Yeah, but it's a bit delayed. It's typical in the monitoring. But yeah, okay, just on time, Gerardo, because we are on the top of the hour.
Well, it's the part of it's what live demos
it's
have.
A fairly complex CNF,
demo, yeah.
so it typically takes quite long. So just on time. So I think this is a good moment to wrap up and thank all the speakers for their presentations, and thank all to you for attending once again an OSM webinar. Thanks a lot for your attention.
Yes, and I would just like to say that I would like to thank all the speakers for all their efforts and for their presentations, and hope that you enjoyed it and can also listen to it at other times. I think that this is also the fact that we have other webinars on this channel, so please keep an eye on the Etsy Bright Talk channel as we make webinars on a regular basis. So after that, I would just like to say thank you very much and goodbye.